Hello and welcome to part 2 of lesson number 4 in Unit 2A, Quadratic Functions, Forms and Transformations in our grade 11 University College math class. This is analyzing the roles of A, H, and K. This is the second part, as I said. The first part was just reviewing what role A, H, and K serve in vertex form of a quadratic. What kind of transformations do they describe and what do those numbers mean? We did a review, we worked through an example, and now we're going to go on to this worksheet. Now the worksheet is your homework as well, so I'm not going to go through all of these. The correct set of answers are actually in your note as well later on. So I'm going to just talk through the first one, maybe two with you here, and then you can tackle the rest for homework and check it against the answers provided in the skeleton note. Okay, let's jump right in here. We're going to skip the first example. It's done for us, although I will say that this piece right here, which was typed into the note when we originally made it, this piece here isn't necessary. If there is no reflection across the x-axis, you don't need to write that. You can just literally not write reflection across the x-axis. Just leave it out. It's not necessary. If it's there, of course, you need to include it. Okay, so let's jump into the second example. Our a value here, again, right out front, that is going to be -2. So a equals -2. Our h value inside the brackets, again, looks like a -3. That will be a +3. Our k value, the constant one hanging around outside, that is also at face value +3. The vertex, a combination of h and k, so in this case it will be 3, 3. That one's the h and that one's the k. And now the X-Intercept question. Like I said, this one's always a little bit tricky, so I always recommend giving it a bit of a sketch here. So here we go. There's the sketch. Our vertex is at 3, 3. Our direction of opening, based on our a value of -2, is down. So when we look at this, we see that there will be 2 X-intercepts, which we will just write down here, 2 X-intercepts. And now we are going to list our transformations. Short forms are okay. I know it's a pretty tiny little box there that we have to put it in. So we have -2. So the first thing we want to note about our a value is that because it's a negative, we will be having a reflection across the x-axis. Reflection across the x-axis. And then we look at the other component of our a value. It's a 2, so that's a number that's larger than 1. So we're going to call this a vertical expansion by a factor of 2. Oops, factor of 2. And then we look at our h and k values. H is a +3, so that will be a horizontal translation 3 units to the right. And if we look at our k value, that's also +3, so that will be a vertical translation 3 units up. So there are our transformations. Let's do domain and range. Now what's nice is the domain, as always, wide open. So the set of all x such that x is an element of real numbers, no limits, thank you ma'am. The range, as always, limited by our vertex. So the set of all y such that y is an element of real numbers, where y and the y component of our vertex was 3. That's our k value, and our direction of opening was down. So that will be less than or equal to, because it was down, 3, because that's the y component of our vertex. So there is an example. Let's work one more. It has a few different types of values in here that we can mess with. Let's have a look at this one. So starting with the a value, again, just hanging right out front, our a value is equal to 1/2. Our h value inside the brackets looks like a +1, is indeed a -1. And our k value +5, and we take that as it is. So k equals 5. The vertex is the h and k values, so -1 and 5. And now the x-intercepts. So let's do a little bit of a sketch again here. So our vertex is -1 and 5, so it's up here. Our direction of opening is up. So you can see that we will not have any x-intercepts. If you want to do that in your head, that little sketch, that's no problem. I'm just showing you how to do it if you can't seem to hold that image, that visual in your head. Now let's get to the transformations. So there's no vertical reflection across the x-axis this time because our a value is positive, so we're going to leave that. We do, however, have an a value that is 1/2, so this is a vertical compression this time, and a vertical compression by a factor of 1/2. Well, we're going to squeeze that in, factor of 1/2, and then we look at our h and k values. So h being a negative value will mean a horizontal translation 1 unit, this time to the left, which is the negative side of the x-axis, and the vertical translation was 5 units, and because it was positive, that's going to be 5 units up, like a cup. And domain and range, domain as always, wide open, so the set of all x such that x is an element of real numbers. Thank you, ma'am. And the range, set of all y such that y is an element of real numbers, where y, and let's look to the the y component of our vertex, it's going to be 5, and our direction of opening is up. So 5 is the number, and because it's opening up, that'll be greater than or equal to 5. So there's 2 worked examples. You guys work through the rest. Again, the solutions are actually attached to the skeleton notes, so you've got that to refer to. Otherwise, good luck with the homework. If you do have any questions or just not sure how we arrived at certain explanations from the homework solutions, reach out in person, via email, or in the class video discussion that we have open every day. So good luck with the homework, and we'll see you in lesson number 5.